Welcome to Xander's awesome tutorial on how to use the X-rite to calibrate the Noritsu test strip. So you got your test strip, right? And this tutorial is assuming you've already calibrated the X-rite. It's usually already calibrated. Not like this though. There's a bit of calibration you should do every day involving this little sheet. You get this guy out, and so you're going to want to go hit menu and then density and then cal. So it says enter cal densities of trans step wedge. That should already be input. I don't really know how to input them if you don't have them there, but they should be there. You just hit continue, and then it says to read it without the step wedge. So what that means is you just put nothing there, and you press this down, hold it, and wait for this to say. It should be pretty close to 0 on all of those numbers. The blue is looking a little bit, that glare is annoying. Blue is a little bit funky right now. It shouldn't be in double digits at all. Interesting. Well, that's why you calibrate it. So now that that's done, take out your step wedge and you go to the cal high right there. This guy. Try to find an area on it that doesn't have scratches. It's pretty scratched up. But once you find a little spot, then boom, hold it down until there's data, and they're going to move around a little bit, the numbers. Just wait until they're relatively stable. Calibration complete. So that's it for calibrating the machine. Now for recording the data. Let me just grab a pen. Okay. So here we go now. You're gonna go to Tran M. Oh no, wait, it's already on Tran M. So you go back to menu, and then I think you do density, and then shit, I forgot. I think it might be plot. Nope. Nope. Oh wait, now that it's calibrated, it'll already be doing its thing. Hang on here. Okay, I think it should be good. It's been a while since I've done this. So I have it laid out on these sheets from the top to the bottom of the test strip. That's what it's going to be. So it starts with Y. There's no particular order, but I just find this the easiest. So put Y there, slam it down, and there are your values for red, green, and blue. You're going to write those down. For Y and Dmax, you don't need red or green, but for blue, we got 2.26 there, so I'm going to write 2.26. Then I'm going to go to Dmax, and it looks like it's 2.67. 2.67. Now HD. Here you're going to record all the numbers. So we got for red 1.64, for green 2.03, yada 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 2.31. LD. You're just going to repeat this until you're done with all the little sections on the test strip, and then I'll show you after how to plot them on the graph. Give me one moment. .31, 0.77, and 1.0. Okay. So now that you got that all done, you don't need the test strip anymore. You just need your graph. And let me just really quickly get this out of the way. Bada boom, bada bing, bada boom, bada bing, bada boom, bada bing, bada boom, bada bing. Alright. hold on. Okay. So you're gonna need a calculator for this, or if you're good at math, you can just do it in your head. But we've got a nice little mini lab calculator here. So for the first part, you're only plotting the blue, and you're gonna take your numbers that you got there for y and dmax, and you're gonna do dmax minus y. So dmax is 2.67 minus 2.26. Wow, this calculator is showing some weird shit. Hello? Okay, I'm gonna grab my phone. Phone calculators are nice. I need my phone. Give me my phone. Dude, come on. Alright. Leaving calculator. Okay. So 2.67 minus 2.26 equals 0.41. And you see here it says 0.47 because that's what it should be at. That's the baseline. In each package of test strips, it'll have this little reference strip that'll just show you what the default stuff is supposed to be. That's what I was talking about earlier in reference to the calibrating test strip. Maybe I'll make another video on how to do that someday, but this is the only thing you're gonna need to know how to do frequently. So 0.41 is what we got. Since that's 0.47, we're gonna do minus 6 because it's 6 less than it should be. Now we're gonna move down to HD minus LD. So 1.64 minus 0.5 is 1.14, and so it's supposed to be at 120. So we'll just write down -6 again. Boom, and draw the little line. Oops. You should use the color that it correlates with. Red. Okay, and then I'll do the same thing for green. So 2.03 minus 0.89, and that's 1.14 again. So that's a little bit worse. What the hell is 122 minus 14? What is that? I guess we'll do -8, I think. If I'm wrong, then sue me. But there it is for green, or no, it'd be 18. 18, Jesus. There we go. Oh, wrong plot point. There we go. Okay. You get the idea. But yeah, and then I'm gonna skip doing that for the blue of HD minus LD, but then this is a little easier because you don't have to do the minus or anything. You just look at what you got for LD and HD, or LD and DMIN, and then you write down the differences, and that should be it. If you see drastic spikes anywhere, probably stop developing or talk to somebody who knows more about the machine. But usually it's fine, unless they're like off the charts or there's a sudden drastic change. Yeah, that's how you use the X-rite calibrator.